Hello friends, now we'll start the new chapter, Circle. This chapter is for 12 marks for the board examination. I will explain all examples from the practice set 3.1. But before that, what we are learning in this chapter? First, circle passing through 1, 2, 3 points. Secant and tangent. Circle touching each other. Arc of a circle. Inscribed angle and intercepted arc. Cyclic quadrilateral. Secant tangent angle theorem, theorem of intersecting chords. Okay, now let us start. You are familiar with the concept regarding circle like center, radius, diameter, chord, interior and exterior of a circle. Also recall the meanings of congruent circles, concentric circles and intersecting circles. Okay, now see this here. These are congruent circles. They have the same radius. Concentric circles. These circles have the same center. And these are the intersecting circles. Now see this here first activity. In the adjoining figure, segment D is a chord of a circle with center C. Segment CF is perpendicular to segment D if diameter of the circle is 20 centimeter. D is equals to 16 centimeter. Find CF. Recall and write theorems and properties which are useful to find the solution of the above problem. Now the first property, the perpendicular drawn from the center of a circle on its chord bisect the chord. This is the first theorem. Next, the segment joining the center of a circle and the midpoint of its chord is perpendicular to the chord. And one more property, the diameter of a circle is twice length of its radius. Okay, now we'll solve this example. Here we draw the segment CD. Angle CFD is equals to 90 degree. In triangle CFD, measure of angle CFD is equals to 90 degree. Therefore, by Pythagoras theorem, CD square is equals to CF square plus FD square. R is equals to D upon 2. Okay. Now here diameter is a 20. Therefore 20 upon 2. Therefore R is equals to 10 centimeter. Next, DF is equals to 1 upon 2 D 1 upon 2 into 16 is equals to 8 centimeter. This is the DF. Now in right angle triangle DFC, CD square is equals to CF square plus FD square. Substitute the value. 10 square is equals to CF square plus 8 square. 100 is equals to CF square plus 64. Therefore, CF square is equals to 100 minus 64 is equals to 36. Taking the square root, you will get CF is equals to 6 centimeter. And this is the answer. That is distance of this chord from the center is equals to 6 centimeter. Now next, second activity. In the adjoining figure, segment QR is a chord of the circle with the center O. P is the midpoint of the chord QR. If QR is equals to 24, OP is equals to 10, find radius of the circle. To find the solution of the problem, write the theorem that are useful. The first is a perpendicular drawn from the center of a circle on its chord bisect the chord. Second, the segment joining the center of a circle and midpoint of its chord is perpendicular to the chord. Okay, now we'll solve this activity. See this here, QR is a chord of the circle with center O. P is the midpoint of the chord QR. If QR is equals to 24, OP is equals to 10. Okay, then find the radius. QP is equals to 1 upon 2 QR. QP is equals to 1 upon 2 into 24. QP is equals to 12. Therefore, here in triangle OPQ again by Pythagoras, OQ square is equals to OP square plus PQ square. 10 square plus 12 square, 100 plus 144. You will get here OQ square is equals to 244. Therefore, OQ is equals to in root of 244 is equals to 2 into in root of 61. Okay. Now, next, hence the radius of the circle is equals to 2 in root of 61. Okay. Now, next activity. In the adjoining figure, M is the center of the circle and segment AB is a diameter. Segment MS perpendicular to chord AD. Segment MT perpendicular to chord AC. Angle DAB is a congruent to angle CAB. Prove that chord AD is a congruent to chord AC. To solve this problem, which of the following theorems will you use? First, the chord which are equidistant from the center are equal in length. Second, congruent chords of a circle are equidistant from the center. And out of this, we will use this first one. Okay. Next, which of the following test of congruence of triangles will be useful? Okay, out of this test, we'll use here hypotenuse side test. Okay, now we'll prove this. See this here, proof. The proof बघणार आहोत आपण यामध्ये. Angle DAB is a congruent to angle CAB. This is given. Segment AB is the bisector of angle CAD. M is on bisector of angle CAD. Next, therefore, MS is equals to MT. That is a point on the angle bisector are equidistant from the sides of the angles. Okay, M is equidistance from the sides of the angle. Therefore, MS is equals to MT. Okay. In right angle triangle, MAS, MAS and MAT. Okay. Segment AM is a congruent to segment AM, which is common. Next, segment MS is congruent to segment MT, and therefore the triangle MAS is congruent to triangle MAT, hypotenuse side test, and therefore AS is equals to AT, CSCT. 2 times AS is equals to 2 times AT, that is multiply on both sides by 2. And also 2 times A is nothing but AD and 2 times AT is nothing but AC. Therefore, from 2 and 3, you will have AD is equals to AC. Means what's chord AD is a congruent to chord AC. And in this way, we have completed this activity. Now next, circle passing through 1, 2, 3 points. Circle passing through 1 point. Now see this here. In this figure, P, Q, R are the centers of the circle. All these circles pass through the point A. Therefore, point A lies in a plane. All the three circles with the center PQR pass through point A, and hence here we will conclude that infinite number of the circles pass through a point. Okay. Now the next, circle passing through 2 points. Okay. From any 2 points, the infinite number of the circle passes through the 2 points. See this here. For this activity, draw segment AB first. Draw perpendicular bisector L of the segment AB. Take point P on the line L as a center, PA as a radius. Draw a circle. If we take P as a center and P as a radius, draw the circle. Observe that the circle passes through the point B also. Okay. Take any point Q on the line L. If a circle is drawn with the center Q and the radius as a QA, will also pass through the point B. How many such circles can be drawn passing through A and B? Okay, again, infinite number of the circle will pass through these 2 points. Okay. And hence we will conclude that innumerable circles passing through point A and B can be drawn. The locus of the center of this circle will be on perpendicular bisector of the line AB. Okay. Now next, circle passing through three non-collinear points. Now see this here. A, B, C are the three non-collinear points. If you join AB, BC and AC, and if you draw the perpendicular to any two sides of this triangle, they intersect at the point O. And if you take O as a center and O as a radius, okay, then there is a single circle which passes through all these three non-collinear points, and therefore there will be only one circle passing through the points A, B, C. Okay, and okay, the circle passing through three collinear points. Okay, take three collinear points D, E, F. Try to draw a circle passing through these points. If you are not able to draw a circle, think of the reason. Okay, now see this your answer. The points D, E, F are collinear points. A circle passing through these 3 points cannot be drawn. There is no point in the plane of the circle which is equidistant from D, E and F. Okay, so circle cannot be drawn as center of circle is not found. Okay, now next, see this here. Infinite circle pass through one point. Next, this is the conclusion. Infinite circles pass through two distinct points. And third one, there is a unit circle passing through three non-collinear points. And the last, no circle can pass through three collinear points. Okay. Now, next, secant and tangent. See this here. The first circle with the center A and the line L. Okay. Next, circle with the center B and M is the line. Touches at the point P, and there is another circle with the center C and line N touches the circle in 2 points Q and R. In the above figure, not a single point is common in line L and a circle with the center A. Point P is a common to both line M and the circle with the center B. Here the line M is called the tangent of the circle, and the point P is called the point of contact. 2 points Q and R are the common to both the line N and the circle with the center C. Q and R are the intersecting point of line N and the circle. Okay. Line N is called secant of the circle. Here the line N is called the secant. Here the line M is called the tangent. Okay. Now next, tangent theorem. See this here theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. This proof is an indirect proof of this theorem. Given line L is a tangent to the circle with center O at the point of contact A. Okay. To prove line L is a perpendicular to radius OA, proof. Assume that L is not perpendicular to segment OA. Suppose that segment OB is drawn perpendicular to L, line L. Of course, B is not same as A. Now take a point C on L such that the point B lies between A and C, and BA is equals to BC. Now see this here figure. BA is equals to BC. Now in triangle OBC and OBA, what's happening? BC is a congruent to segment BA. BC is congruent to BA. This is a construction. Angle OBC is a congruent to OBA, each right angle. Next, segment OB is a congruent to segment OB. Okay, and it is a common. Therefore, the triangle OBC is congruent to triangle OBA. OBC is congruent to OBA by SAS test. Now next, therefore OC is equals to OA, but the segment OA is a radius. Therefore segment OC must also be radius. C lies on the circle. That means that the line L intersects the circle in two distinct points A and C. But line L is a tangent. It's a given. It intersects the circle in only one point. Our assumption that L is not perpendicular to radius OA is wrong, and therefore line L is a perpendicular to radius OA. Okay, and in this way the proof is completed. Now next, converse of a tangent theorem. What is that theorem? A line perpendicular to a radius at its point on the circle is a tangent to the circle. Okay, now see this here, the figure. M is the center of a circle. Segment MN is a radius. Line L is perpendicular to segment MN at N. To prove line L is a tangent to the circle. Now proof. Take any point P other than N on the line L. Draw segment MP. Now in triangle MNP, angle N is a right angle. Segment MP is a hypotenuse. Therefore, segment MP is greater than segment MN. As a segment MN is a radius, point P cannot be on the circle. Okay, no other point except N of the line L is on the circle. Okay, and therefore line L intersect the circle in only one point N, and therefore line L is a tangent to the circle. Okay. Now next, in figure, B is a point on the circle with center A. The tangent of the circle passing through B is to be drawn. There are infinite lines pass through the point B. Which of them will be tangent? Only single line is a tangent to this circle, which is perpendicular to the radius of the circle. Okay. Can the number of the tangent drawn through B be more than one? No. Only single tangent we can draw through the point B. Okay. Next, point C lies in the interior of the circle. Okay. Next, can you draw tangent to the circle through C? We cannot draw the tangent through C. If we draw the line through the point C, it will intersect the circle into distinct point, and therefore it is not the tangent, then it is a secant. Okay. Now next, point D is in the exterior of the circle. Can you draw a tangent to the circle through D? Yes, we can draw two tangent through from the point D. Okay, these are the two tangents, that is a PD and a DQ. Okay. Now in the adjoining figure, line DP and the line DQ touch the circle at the point P and Q, and therefore segment DP and the segment DQ are called tangent segments. Okay, these are called the tangent segments. Now next, tangent segment theorem. So this here, the tangent segment drawn from an external point to a circle are congruent. Okay. Now given A is the center of the circle, line PD and the line QD are tangents to the circle at point P and Q respectively. To prove that segment DP is congruent to segment DQ, now join PA and QA. Okay. Proof. In triangle PAD and the triangle QAD, segment PA is congruent to segment QA, the radii of the same circle. Next, segment AD is congruent to segment AD, common side. Angle APD is congruent to or equals to angle AQD, that's equals to 90, tangent theorem. And therefore, triangle PAD is congruent to triangle QAD by hypotenuse side test, and hence here segment DP is congruent to segment DQ. CSCT, corresponding sides of congruent triangles. It's very easy theorem. Now solve examples. It is here. In the adjoining figure, circle with center D touches the sides of angle ACB at A and B if angle ACB is equals to 52 degree. Find the measure of angle ADB. Okay, measure of angle ADB. Now the solution. The sum of all angles of quadrilateral is a 360. Therefore here measure of angle ACB plus measure of angle CAD plus measure of angle CBD plus measure of angle ADB is equals to 360. Substitute the value 52 degree plus 90 degree plus 90 degree plus measure of angle ADB is equals to 360. Therefore measure of angle ADB and sum of all this 90 plus 90 plus 52, that's equals to 232 is equals to 360 degree. Therefore measure of angle ADB is equals to 360 minus 232. Then you will get here 128 degree, and hence measure of angle ADB is equals to 128 degree. Okay. Now next example. Point O is the center of a circle. Line A and B are parallel, tangent to the circle at P and Q. Prove that segment PQ is a diameter of the circle. Here we have to prove that is a P, O, Q are the collinear points. Now we'll prove that these 3 points are collinear. Then we'll prove that the PQ is a diameter. For that, draw a line C through O which is parallel to A. Okay. Draw the radii OQ, OP, OQ and OP here. Now the angle OPT is equals to 90 degree, tangent theorem. Therefore the angle SOP is equals to also 90 degree. SOP is 90 degree, interior angle property. Okay. Now line A is a parallel to line C. This is our construction. Line A is a parallel to line B. This is given, and therefore line B is also parallel to line C. Okay. Now the next, therefore angle SOQ is equals to 90 degree, interior angle property. Next, from 1 and 2 here again, see this here, these two property, that is measure of angle SOP, measure of angle SOP plus measure of angle SOQ is equals to 90 plus 90, that is equals to 180 degree. Okay, therefore ray OP and the ray OQ are opposite ray, therefore POQ are collinear points. Okay, and therefore the segment PQ is a diameter of the circle. Okay, now we'll start the practice set 3.1. Now first example, in the adjoining figure, the radius of a circle with center C is a 6 centimeter. Line AB is a tangent at A. Answer the following questions. What is the measure of angle CAB and Y? Okay, now the solution. Measure of angle CAB is equals to 90 degree by the tangent theorem. Okay. Next, second question. What is the distance of point C from line AB and Y? Now the solution. Segment CA is perpendicular to line AB. CA is equals to 6 centimeter given. C is a point at a distance of 6 centimeter from line AB. Okay. Therefore, the distance of the point C from the line AB is equals to 6 centimeter, as C is perpendicular to line AB. Okay. Now next, in the adjoining figure, the radius of a circle with center C is a 6 centimeter. Line AB is a tangent at A. Okay. Answer the following question. Distance AB is equals to 6 centimeter. Find BC. Okay. Now in triangle CAB, what's happening? CAB is equals to 90 degree by Pythagoras theorem. CB square is equals to, okay, this CB square is equals to CA square plus AB square. Therefore, BC square is equals to CA is a 6 and AB is also 6. 6 square plus 6 square, that is equals to 36 plus 36. BC square is equals to 72. And if you take the square root on both sides, then you will get here BC is equals to 6 root 2 centimeter. Okay. Here the distance BC is equals to 6 root 2 centimeter. Okay. Now the next, what is the measure of angle ABC and why? In triangle ABC, what's happening? CA is equals to AB, each of 6 centimeter in length, and therefore angle ABC is equals to angle ACB. Next, measure of angle ABC is equals to measure of angle ACB is equals to x degree. Now, in triangle ABC, see this here, measure of angle CAB plus measure of angle ABC plus measure of angle ACB is equals to 180. Sum of all angles of triangles is 180. CAB is a 90. ABC plus ACB, that is x degree plus x degree, you will get here 2x degree. 180 minus 180 degree minus 90 degree, you will get here 90 degree. Therefore 2x degree is equals to 90 degree. X degree is equals to 90 upon 2. Therefore x degree is equals to 45 degree. Therefore the measure of angle ABC is equals to 45 degree. Now next question. In the figure, O is center of the circle. From point R, segment RM and the segment RN are tangent segment touching the circle at M and N. If OR is equals to 10 centimeter and the radius of the circle is equals to 5 centimeter, then what is the length of each tangent segment? Now the solution. Draw the segment OM and ON. In triangle OMR, angle OMR is equals to 90 degree, tangent theorem by the Pythagoras. OR square is equals to OM square plus MR square. 10 square is equals to OM means what? 5 square plus MR square. Therefore, MR square is equals to 100 minus 25. Next, MR square is equals to 75. If you taking the square root on both sides, MR is equals to, in root of 75 means what? 25 into 3. The square root of 25 is a 5. Therefore, 5 root 3 centimeter. Therefore, MR is equals to 5 root 3 centimeter. And hence, RM is equals to RN is equals to 5 root 3 centimeter. That is a tangent segment theorem. Now, next, what is the measure of angle MRO? Measure of angle MRO. Now here, in triangle RMO, what's happening? Measure of angle OMR is equals to 90 degree. OM is equals to 5 centimeter. OR is equals to 10 centimeter. OM is equals to 1 upon 2R. Corners of 30, 60, 90 triangle theorem. Therefore, that is the side opposite to angle 30 is half of the hypotenuse. Okay. Therefore, the measure of angle MRO is equals to 30 degree. Okay. Similarly, measure of angle NRO. NRO is equals to also 30 degree. NRO is also 30 degree. Okay. Now next, what is the measure of angle MRN? Okay. Now the measure of angle MRN is equals to MRO plus NRO. यापूर्वीच आपण फाइंड आउट केले ते 30 degree plus 30 degree. You will get measure of angle MRN is equals to 60 degree. Okay. Now next, see this figure also. Okay. Now next question. Segment RM and the RN are the tangent segment of a circle with center O. Prove that segment OR bisect angle MRN and angle MON. Okay. Now in triangle RMO हा triangle consider करणार and the second is a RNO. In this triangle angle RMO is equals to angle RNO is equals to 90 degree. Tangent theorem. Hypotenuse OR is congruent to hypotenuse OR. Common side. Side OM is congruent to ON. Radii of the same circle, and therefore the triangle RMO is congruent to triangle RNO by the hypotenuse side theorem. And again here the angle MRO is congruent to angle NRO, and the angle MOR is congruent to angle NOR. Okay, CACT. And therefore segment OR, this segment OR bisect angle MRN and angle MON. Okay. Now next, here, what is the distance between two parallel tangents of a circle having radius 4.5 centimeter? Justify your answer. Now the solution. Let the center of the circle be O. Let the tangents A and B touches the circle at points M and N respectively. Okay. Draw segment OM and ON. Okay. Through O, draw line XY parallel to line AB. XY is a parallel to AB. Line AB is a parallel to line CD. AB is a parallel to CD. It's a given. Okay. Therefore, line XY is a parallel to line AB. This is a construction. Okay. And hence, all the three lines, that is AB is a parallel to XY is a parallel to CD. Okay. That is measure of angle here. OMA, measure of angle OMA is equals to measure of angle ONC. OMA is equals to ONC, that is equals to 90. Tangent theorem. Line AB is a parallel to line XY. AB is a parallel to XY, and the line MO is the transversal. Therefore, measure of angle AMO plus measure of angle MOX is equals to 180. Interior angle theorem. Therefore, this 90 degree plus MOX is equals to 180. Therefore, measure of angle MOX is equals to 180 degree minus 90 degree. You will get here measure of angle MOS is equals to 90 degree. Similarly, NOX is equals to 90 degree. And hence here measure of angle MOX plus NOX is equals to 90 degree plus 90 degree, and that is equals to 180 degree. Angle MOX and angle NOX are adjacent as well as supplementary. Okay. Therefore, angle MOX and angle NOX are a linear pair, and therefore ray OM and the ray ON are opposite rays. Points MON are collinear. Okay, as the point MON are collinear, MN is the distance between the parallel tangents AB and CD. MN is equals to 2 into radius. Therefore, MN is equals to 2 into 4.5. Therefore, MN is equals to 9 centimeter. Okay, and hence the distance between parallel tangents is 9 centimeter. Okay, and in this way we have completed this practice set 3.1. Now we'll see in the next video. Till then, goodbye.